In this particular video, we will study about one of the most important and the simplest instrument, or let's say an optical instrument in hand, that is lens. It uses a principle of refraction across two spherical surfaces, that is spherical surface on one end where it enters from a particular medium to the glass, and the refraction through the other surface where it exits from glass to the other medium. So we will describe everything about lens, that is starting from lens maker formula to the lens formula itself, and also describing its applications. So let's see what do we have when we study lens. Now we shift our attention to lens. Lens being a very important instrument or tool, so as to put it, as far as the refraction is concerned. Every sort of refraction which we use in our day-to-day life, let's say eye or the lenses exactly which you know of, undergoes refraction through spherical surfaces. So for as far as the aspect of refraction from spherical surfaces are concerned, lens is the tool to study about. So let's start off with lens. So in these topics associated with lens, what we will do is we'll come up with a similar context, that is of that of mirror over here. Mirror being a very important or the most important aspect of reflection, use of reflection. So we came across mirror formula. In this aspect as well, lens is very important as far as refraction is concerned. So we will come across lens formula. So let's get going, or how we will come up with lens formula. Okay, so let's start off. So this is a lens, NL being the two top points of lens, mu1, mu2, mu1. I need two surfaces because lens will have one refractive index, and the surfaces across which it's going to refract and throughout the light has to have the same refractive index. That is as far as simplest case is considered. So we are right now studying the simplest case, that is I have mu1 across lens of refractive index mu2. Principal axis, P1, P2 being the poles of the two surfaces, C the center of the lens, C1, C2 being the radius or the center of curvature for the two surfaces over here. So C1 will correspond to the center of curvature of this sphere, C2 will correspond to this. Sorry, it's the other way around, that is C1 will correspond to this and C2 will correspond to this. Now the incident ray from a particular object goes like this. I end up getting image at I1. So this is in general. So from this, from all the notation A, C2, P1, C, P2, C1, I1, N1, N2, we will have to come across a lens formula that relates object distance, image distance and the refractive index. R1 and R2 being the radius of curvature. So obviously I am looking out for something which relates U, V, R1, R2. So I have U, V, R1, R2, and I also have mu1, mu2. I want something which relates all of them together. So that's where lens maker formula kicks in. So if you give me a particular setup, that is I have concavo convex, convexo concave, plano concave, plane refracting surfaces, any type of refracting surface you throw at me, that is a combination of two refracting surface, one which is facing an incident light, the other one which is throwing out the refracted light. So I need two surfaces, two refracting surfaces. If you give me those two refracting surfaces, their refractive indices and the refractive index of this surrounding, I'll come up with a formula which effectively tells me how good the lens is. That is given by lens maker formula. So I will exactly find out what lens maker formula is by simply applying refraction through spherical surfaces.